Welcome to Plugged In, a podcast by Okefenokee REMC about our co-op, our community, and our shared connections. I'm Michelle Hutchins, your Communications and Marketing Coordinator. And joining me today is Manager of Engineering, Darren Cruz. Darren, thanks for coming in.
You're welcome.
So we're going to be talking about system improvements over the last couple of years on our distribution system because we've had a lot go on over these, it seems these last 2 years in particular. We've got some new substations. We've rebuilt some substations. We've upgraded lines. We've built tie lines. We're expanding our distribution automation. And so there's a lot there to talk about.
A lot.
Let's back it up, break it down, and maybe start at the beginning. I think the one that we talked about maybe diving into first was our Nahana substation that was rebuilt in 2022.
So that project to expand Nahana was in order to increase capacity at that substation as well as provide additional capacity to serve other stations in the event that we were to lose one of our area stations. So it's an area-wide solution. In addition to that, our largest industrial customer to date was served out of that station, or is served out of that station. So we were doing that to also provide good, reliable service for that customer as well as our other residential customers in that area. So that project involved two different entities, us and another utility. So there was a little bit of difficulty with the coordination that you have, the extra coordination that you have. The project for us was done in conjunction with Georgia Transmission, who takes care of building our substations for us. Our engineering team works with their design team to get the facility that we need to serve our members. So that project was quite the task. All of that had to take place, of course, while we continued to serve those loads out of that substation.
So construction occurred while it was still live.
That station was energized for the most part the entire duration of the project. There was about 5 weeks that we did have to shift the load away from that station in order to be able to do construction efforts inside the fence at the sub. So we pick a time when weather is more favorable and loading conditions are more favorable.
And we probably should back up just a little bit, explain a little more about a substation. So we refer to our electric grid that serves our local members as our distribution system. So a substation, and we have several of them. How many do we have total? 19. So we have 19 of these across our system, and that's where the more high-powered energy is delivered to our system. That is called the transmission system, comes to the substation, delivers to our distribution system. I think maybe just talk about that a little bit so folks understand why it's important to have a substation that can handle all of this incoming and outgoing.
So the larger lines that you see in our area that crisscross our area, they're transmission lines.
With the big metal towers.
Typically in our area, they're 115,000 volts. So we call it 115 kV. Okay. So once that line is terminated inside of a substation, we then step the voltage down again to a 25,000 volt level or 25 kV level. And then that's what is actually on the distribution lines.
Gotcha.
So that transformation occurs within a power transformer that's installed in each of the substations. That power transformer is one of the key components of a substation and by far the most expensive piece of equipment in the substation. As well as the capacity, it also dictates the amount of load, the maximum amount of load that we can serve out of that substation. So that is our limiting factor, the size of that transformer. Oftentimes, as loads grow over a period of time, that substation will become loaded to a point that we need to expand and replace that with a larger unit. And in this case, instead of replacing the existing unit with a larger unit, we put in a second unit.
Okay.
And that's important because that allows us the ability to perform maintenance on one unit or the other in case that, and we will have to perform maintenance on all of these units at some point. But that allows us the ability to shift the load bank to bank and not have to interrupt service to anyone or rely on other substations to provide that load.
So something else, just to kind of break it down a little bit, is within a substation, once the power is stepped down, is then delivered out, as we said, to our on various circuits. Meaning, if we want to compare it to a highway system, the transmission system is the high speed, high powered superhighway. Our distribution system is maybe more like a Highway 82 or US 1, and then individual
down.
side roads from there. So how many circuits did the Nahana sub have before, and how many does it have now?
So the Nahana substation originally served 3 circuits
Okay.
out of the original substation, and with the new station, we have the capability of serving 6.
Okay.
So when we rebuild these stations, we plan ahead in most cases to allow for growth, and that would be in the event we needed to add an additional feeder for maybe a industrial load, or occasionally for reliability reasons we will split a feeder, and just because one feeder may have schools or things like that on it.
Sure.
We will split those out sometimes and try to share that load between 2 feeders to improve reliability.
Well, and I think when we look at emergency situations, schools and hospitals and churches, those are areas where people can more safely gather, and isolating those so that they can be turned on sooner is one of those long-term strategic service goals we have to look at in those types of situations.
That is correct. Storm shelters and things, especially in our area with hurricanes.
So I didn't mention it at the beginning, but one of the obviously growth on our system in terms of demand for electricity for an industrial load, but as well as just growth of the number of new service connects. We're a growing co-op at this moment in time.
Yes, we are.
Our residential load is been steadily increasing, particularly since COVID.
Yes.
So, that's one of the reasons that the Nahana sub was, but that was planned and built out kind of in the strategic plan long before COVID hit.
Oh, yes.
But we most recently also just finished another rebuild, and that was on our Hi-Hat substation down by our Kingsland office. Talk about what motivated that one. And
So Kingsland, Hi-Hat substation in particular, and the Nahana substation were of similar vintage. So You're looking at a facility that's roughly 40 years old or so.
Okay.
So the technology and the construction efforts that were used back then,
and the needs,
and the need, it's reached the end of its useful life, and for maintenance reasons and reliability reasons, we needed to upgrade both of those stations. The driver behind Nahana was primarily residential growth.
Okay.
We do have at that time the largest industrial load was served out in Nahana. So that drove the Nahana project. On the Hi-Hat project, we had identified the need for that project, but we had not reached a point to where it was financially justifiable to do that project.
Okay.
However, we did have a new industrial customer come into that general area, and in doing so, it forced us to make modifications and upgrade that station to increase the capacity for this new industrial customer. So that was the spark we needed to go ahead and finish up the work at Hi-Hat substation and initiate a project.
So we've rebuilt 2. I mean, we're growing, particularly in Glenn, Camden, and Nassau counties. Do we have other substations slated downline to be rebuilt?
We do. There are two other stations that are slated to be built right now. There's in Waverly area, we'll be rebuilding, or we will actually build a new facility in the Waverly area.
No?
That station in Waverly is Okefenoke's oldest meter point, and it will be rebuilt with a new modern station. We'll also be, right now we're into the development stages, but it's for the justification, but we also have a station that will be built down south in the Georgia Bend area of our system, and that will support that area as well, the St. George, McClenny, and down in the Taylor area. So
Capacity has really been driving kind of the rebuilds of these two, but you said we had 19, but we have 19 because two new substations came online in the last about year and a half.
So we do have two new substations that are online. One of those stations it's called Kent. It's down in the Callahan area, and that is a large facility with dual transformers in it, and it's used to serve that Callahan, St. George, West Nassau, to bridge that gap and serve those areas out there where we're seeing growth, most likely from urban Jacksonville moving out into the countries. So we're seeing that growth in our area and our service area. So that facility will help provide reliable service for that area.
And anticipating that.
Anticipation of continual growth.
Yeah.
And the other new facility is unique in that we discussed earlier the need to take the 115 kV voltage and step it down to 25 kV for distribution. Mm-hmm. But the new Kinlaw station is unique in that it is actually a 115 substation that provides service to a large industrial account. And they had their own site substation that does the transformation. We just provide them the higher voltage and meter that higher voltage to them, and then they take and do their own transformation. And part of the reason behind that was the 25 kV service that we offer was not what they needed for their industrial application.
I gotcha.
So they chose to use their own substation and transformation rather than to comply with our 25 kV.
Which is our standard.
Which that same large industrial account also has a 25 kV service that we do serve from Hi-Hat substation.
Okay.
So they have both.
They
have both.
Lots of capacity and need. One of the other aspects of growing the system, rebuilding the system, and enhancing the system, the other kind of parts of that stool, if you will, are redundancy and resiliency. All of it's about reliability. So, in addition to the new substations, we're also connecting these substations.
That's right.
More so than we had before, both at a transmission level and at a distribution tie line level. Can you explain what that is, what the difference in the two are, and why they're important?
So I'll address the transmission tie line first. We, as part of the Nahana project, Nahana substation rebuild project, part of that was to also, Georgia Transmission constructed a 12-mile, 115 kV line from Nahana to Hoboken substations to bridge a gap. Basically, Nahana substation was radially fed. In other words, it was at the end of a line. It had no other back feeds.
Gotcha.
It was at the end of the line. Well, Hoboken was in the same condition from a transmission standpoint. And given that fact, once that line was built between Nahana and Hoboken, it enabled us to be able to serve Nahana, Hoboken, and a substation that's owned by Satilla EMC. It allowed us two ways to feed all of those substations from Blackshear or the Hortense side. We had an opportunity there, and we have, with the storms, we've used that a couple of times already. So it was very important to have that backup feed on a transmission level. Now, moving down into distribution, into the things that we actually construct and build and design, those distribution lines are the key to tie. It's feeders coming from a substation, but they butt up to a feeder that's coming from another substation, and there's an open switch there. But we have the ability to serve and backfeed into other areas when needed, like storms or even in just any kind of restoration or construction efforts. We often use that during our construction efforts to maintain service while we're building new lines. So we have worked in particular one from Waynesville to Brookman area along Highway 82. We built a new line that tied those two substations together. Prior to that, Brookman had no ties. It was on an island. But now Brookman is tied to Waynesville through this new circuit, and we can backfeed into Brookman in case we were to have to conduct maintenance on a power transformer, or if we had some type of failure within the substation, we have the ability to serve those members from Waynesville.
So that leads me to, about kind of into some of these line upgrades. So, obviously, driving down Highway 82, we already had power line, but we've upgraded it to 3-phase. And so that 3-phase is what you're talking about. So now there's more capacity and it's tying the two.
So actually, the line that's along 82 from the solar facility to the Brookman area did not exist. That was brand new.
That's brand new.
We had to bridge that gap. Once that gap was bridged and we had a circuit, we were able to, we can serve that load, backfeed that load. And so as an additional part of that project, there's also a project along Highway 99 to rebuild and bridge any gaps that we have in that line all the way through to the Sterling area. We have a substation called Highway 99 and on Highway 99. But so at the end of the day, you'll have the ability to serve Brookman from either Waynesville or Highway 99, as well as Brookman can help serve the other two substations, or Sterling can serve. It gives you a three-way option there to eventually be able to serve these loads.
So to kind of just sort of help paint the picture a little bit more. So we said earlier we have 19 substations. We've talked about, the couple of new ones. One is dedicated to a large industrial load that is new to our system. But the others are all there generally to serve existing and potential growth needs. And so the reason you have substations throughout the system is obviously for better service, so that the delivery from the transmission side is closer to where it's actually the end user side. Is that the best description?
There's a strategy used. So the best scenario is when you can build a substation near transmission facilities. That's cheaper and better in most cases, but oftentimes that also requires distribution upgrades to be able to utilize this new substation to get those feeders and out to the different areas that you need to serve that are maybe under, that you don't have as many options to backfeed and things of that nature. So in doing that, when you site new substations, you're always trying to think about putting those near what we call the load center. It doesn't always work out right because you don't have transmission lines everywhere. And there's also geographical things that stop it, like a swamp or a creek or a river, things of that nature. So we try to balance that and do the best we can in planning and how we lay those sites out.
Just to help our members better understand the role of the substation, and that you can't just have one delivery point to our distribution system. It's just not efficient way of operating. And then if that one line's down, the whole system's down, and nobody wants that. So I think that's an important part, is that we have substations that are located near our load centers, so that so that power is being delivered primarily through the one nearest to where you live. But with the rebuilt substations, with the new substations, and with line upgrades and tie-ins, what it allows us to do is increase redundancy, meaning there's more than one way to get your power, and reliability, because if it goes down coming through this substation and they're connected, well, we can backfeed you that way. And so that is the benefit of doing some of these system improvements and upgrades that you've been talking about.
Ultimately, you would want to be able to backfeed every substation and have redundancy, ultimate redundancy there. We're working towards that. That's a goal. Mm-hmm. There's also the financial aspects. You have to balance those things out, and we have to prioritize projects. So we continually work towards that. And the fact that we've been so busy lately is just a testament to the growth that we've experienced in the past few years.
Yeah.
So.
You talked a little bit about Highway 82 project, Highway 99 project, but we also had US 1 in Florida. You want to talk about that one a little bit?
So that one, that actually occurred before Highway 82, down south of the Folkestone area, between Folkestone and Hilliard in the Boulogne area. It creates almost, if you could think about it as a star. There's several feeders that come into the area from different substations and things. So that allows us, when we rebuilt US 1 and three-phased that with better conductor, and it was time. It was end of life. It was time to rebuild that circuit. That enabled us to be able to do a couple of things. One was to go into the area. Now we have added capacity on the line, so we can tie things. Because one of the key components to being able to tie these lines to be redundant is the capacity of the line itself. Okay. The conductor is not one size fits all. There are various sizes of conductor. By increasing the size of conductor, it enables us to be able to serve heavier loads.
And when you say increasing the size of conductor, you mean increasing the amount of energy the line can
ampacity.
carry.
It's all about the ampacity.
Okay.
It is, yes. So we increase the ampacity, and that allows us to have that ability to tie lines. And then I know we'll get into it later in the discussion, but it also enables us a chance to add downline devices and protective devices into our system as well.
Well, and that's actually where we're going next. But one of the points that I want to make is we talk about what our distribution system is made of. I mean, to deliver power, it is over lines that conductor that are either strung overhead on poles or underground. And I mean, that technology has not changed since since power lines originally began being built. And you know, we're an 84-year-old co-op, so our first lines went up and we first energized in 1940 after formulating in 1939. But technology is changing our system, yes, and it is enhancing it and allowing for automation where previously it was a manual labor. So that's where we talk about distribution automation. And I guess one of the easiest ways, people see their lines blink, their power blink. Sometimes it goes blink, 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 and then it stops or power goes off. To kind of give a little background on what distribution automation is and how it's a huge leap forward in terms of our system design and reliability.
So I'll start first, just in general speaking about distribution automation. That's a very broad term. Mm-hmm. That can lead you down a lot of pathways. In our case, for what we're doing with distribution automation, I want to back up something we said earlier. It's very important that for distribution automation to work, you've also got to, have substations that can absorb the additional load when you do a reconfiguration on your distribution system. Mm-hmm. So whether it's manually done or automatically done, it doesn't matter. The substation still has to be able to accept that additional load. Okay. And even broader than that, so does the conductor. The conductor has to be of ampacity to be able to absorb that additional load and be able to handle that load without burning down or whatever. So
So A has to happen before B.
it is a very systematic approach on how you do this.
Gotcha.
And we've done a lot of work on tie lines. We've done a lot of work on substations, and even I would say to venture that transmission line that was built between Nahant and Hoboken was part of that.
Sure.
But as you move down, when we work on these different feeders and we modernize and replace the conductor and upgrade conductor on feeders, we do that with the distribution automation in mind. And we also go back and revisit all the protective devices that are along these feeders that cause your lights to blink. That's by design. That is allowing whatever trouble happens to be on that line an opportunity, the tree to fall through the line or fall off the line, and then the device closes back in to test and see if the
Working.
problem is gone. If the problem's still there, eventually it's going to turn your lights off. But that is planned, and that is part of it. So as we move forward with these protective devices, they are no longer just dumb devices out in the field that's oil field devices. Now they're high-tech devices that can be remotely operated. We know exactly when they operate because they tell us that via cellular right now.
Mm-hmm.
Probably in the future, they'll all be on fiber at some point. Right now, we utilize cellular technology for the most part to communicate with those downline devices. But being able to have a system operator in our dispatch area close and open these switches or get feedback from these switches to tell us what's going on, that's a big help to the linemen who are out actually restoring the line or troubleshooting the lines.
And so this is the it's currently, but it is the future. The more that technology we add on downline devices and enhance the system. We've talked about that. I know I've seen a little demo configured in the lab that at some point we will get to self-healing, which we're not at, but the self-healing would be so fast that, no one would even realize there was an issue, or the majority of people would.
Yeah, only the people in a
small.
Self-healing is driven by the ability to have fiber networks to each of those devices to the larger, more prominent devices, I would say. You still have the smaller devices downline, the smaller reclosers, but our three-phase reclosers that are online and we can communicate with via cellular, they enable us to be able to reconfigure lines and tie lines together. And that ability, there is another technology you have to put in place that basically oversees that and makes decisions, but it's a computer that's doing that. It's a controller. It's called a DAC, Distribution Automation Controller. And basically it's taking feedback from all of these devices and it decides where the problem's at. It isolates that segment where the problem's at, and it energizes everybody else's, reconfigures and energizes everyone else but the faulted section. So ideally that's where we're headed in the future. It takes time to get there. Right now, I would say we're really working on substation facilities. We're really working on tie lines. We are going circuit by circuit to modernize our equipment. Once all of that is in place, then we'll be set up to get the fiber to each of these devices and move forward with the controller to basically do that automatically. Now, there's always manual overrides for those things for safety reasons. There's always a manual override. And restoration, when you put it back, put the system back to a normal configuration, in most cases that would require a manual operation to initiate that at least.
So kind of as a summary, I want to point to an article that was in our printed newsletter, be a couple years ago now, and I had a conversation with Kane,
Right.
Lee, our engineer, who kind of is the lead on much of
He's
this.
our reliability engineer.
A reliability engineer. And you know what? One of the things that he and I talked about is our goal is obviously that we would have no outages. I mean, that is ultimately the goal. But unfortunately, there's too much that's not in our control.
Too much.
Too much, whether just acts of God, whether, other cars, animals. I mean, there's just too many things that we cannot control. We can anticipate, but you still can't control the impact the system. So as we look toward the structural rebuild and enhancement of the system, then adding on the distribution automation components, our focus then says, okay, well, if we can't realistically achieve zero, what we can achieve is an outage or a power disrupting, impacting the fewest number of members for the shortest amount of time. And that's kind of what you were just describing with the self-healing.
That is our engineering group's motto. We want to minimize the impact, minimize the number of members, and minimize the amount of time that it takes to restore.
So, times and speed of life have changed drastically since 1940. And no doubt there's probably a desire that we could be in the future sooner, but we're working toward it. We're building toward it, and
it's a work in progress. And as your feeders change, that's one thing about our system. It changes as a subdivision comes on. It changes the dynamics of that feeder, and even in some cases, the protection of that feeder. So we're always growing, and this will be something that we continue to chase in our careers. But I think that soon enough, as we get our substations in place and we get the tie lines rebuilt, we'll be ready to move forward with that self-healing, and the fiber part will have to come into play, which that can be done in conjunction with other things.
So a lot to it, for sure.
A lot to it.
Hopefully this gave a little bit of a picture as to all the intricacies and everything that we at Okefenokee REMC are doing to enhance that reliability so you have service consistency. So
we're working on it.
Thanks for listening, and we'll see you next time.